we're going to start off with two talks from two of my friends here, going over, I think, both the sort of runtime environment, kind of, I think, what to put it in a funny way, the secret part of running Kubernetes successfully is as a product, as we'll get into with Hannah. And then also looking at the way that when you're starting to do your applications or even thinking about updating your own, what's the best way to go about architecting and designing them. Now, throughout these talks that we'll be getting to shortly, if you have questions, please put them in the chat and we'll try to answer them in the chat, probably not while Jakob and Hannah are speaking. That would be great if they could do that, but I think that's beyond anyone's powers. But we'll answer it afterwards. And if we have any time left over, we'll answer them in voice here. And then we'll split off from that to the workshops. Now, there's two instances of the same workshop going on that will be hosted by several people, instructors, who can help you throughout that. So you can choose which one you want to attend. And there'll be Dave Sire and Ollie Hughes doing one of them, and Alexei Nestorov and Oded Chopin and another one. And you'll get the treat no matter which one you're in. Alberto will be going through both of them. So you'll be able to spot him. It'll be like, where's Alberto? You can see where he shows up. And also, you know, in case you don't get all the way through to the end, you can find we're going to put a link to the workshop information to get in the chat window. I won't read the URL to you. It's quite long. And finally, as mentioned, if you want to check out more, you should go to our developer center. And we do shows mostly every day at tanzu.tv, including one from me and several of the people you see here. And we also have our great conference coming up September 1st and 2nd, SpringOne tours. And I'm sorry, it's SpringOne. It's going to be full of all sorts of stuff on the developer side, the operation side, and as I mentioned earlier, the meatware side, all sorts of thrilling stuff there. So, and after the event, we'll send out an an email with all of this information and details, the things that you would want. So with that, let's start off with the first talk, which I'm always excited to see. So we have Hannah coming up, and what she's going to go over, I think, is, as I've worked with large organizations over the past several years, one of the things that she's going to go over, what I've noticed really makes a difference for their ability to create modern types of cloud native applications and be successful with the Kubernetes platforms they have up and running. And I don't want to give away too much, but just kind of pay attention to the mindset and the way of setting up the process that she goes over, because I don't think you'll get that perspective from many other people. So with that, I'll hand it over to Hannah.
Thanks, Kote, and morning, everyone. It's really great to be here. As you said, today I'm going to talk about two things: people and platforms, and how we bring those two together to help us deliver applications. How do we take a human approach to the work that we do? So my name's Hannah. I work at VMware Tanzu Labs. So it's my job this morning to talk to you about how to be successful with Kubernetes. This is my day job. Because let's be honest, everyone's talking about Kubernetes right now. It's ubiquitous. Kubernetes is everywhere. The container scheduler wars are all but over at this point, and Kubernetes has emerged the victor. Doesn't matter whether you're DIYing your platform from open source or opting for hosted services or something in between. There's no doubt that the community is really converging around Kubernetes as that common abstraction layer for managing that complicated, difficult gray area that lives between an application and infrastructure. Kubernetes is becoming commodity, and there are benefits of that, obviously: consistency, standardization, but also innovation. One of the most powerful things about Kubernetes is the API. It's so highly configurable and extensible that you can build on top of Kubernetes to provide your teams with fully featured application platforms. And I'll talk a little bit more about what I mean when I say application platform in a minute. But this flexibility within Kubernetes has created a groundswell in innovation, open source projects that can extend Kubernetes, giving teams additional tools to manage their containerized applications, really providing a better user experience for application developers who are working with containers today. It wouldn't be a Kubernetes talk without the obligatory CNCF landscape slide, would it? But I think it is a perfect illustration of the incredible innovation that's happening around Kubernetes, to extend it, to build on top of it, to make it better and to make it more usable. But it's also a daunting prospect for the people who are working in this space, not just people who are new to this technology, but for people who aren't so new, people who have been here for a while. The pace of change and the rapid innovation feels very difficult to keep up. And so I'm going to sort of advocate today for really keeping it simple, and figuring out ways that we can navigate this complexity to actually deliver the platforms that our application teams need. It's been said that Kubernetes is a platform for building platforms, and I absolutely agree with that statement. And it lets you interact with your infrastructure in a really application-centric way. You declaratively set, the requirements of your applications with the application that you're deploying. You can set limits on resources such as RAM and CPU rather than them being static. This can become much more dynamic and application-centric. And Kubernetes then takes all of those settings and says, hey, I've got an app, where shall I run it? And it takes care of the scheduling for you. It says, hey, I've got a node over here that's got the right resources available for my application. I'm going to put this container over here. And it takes a lot of that complexity away from the humans. So it's incredibly powerful from that perspective. Talking about applications a little bit more though, the applications that your team and your organization need to do the thing that you do as a business are going to be unique to you. Those applications are going to dictate the platform that you need to build. This isn't a one-size-fits-all problem. No two businesses are the same. No two businesses have the same application portfolio. And so it stands to reason for me that no two businesses need to solve the platform problem in exactly the same way. There are obviously patterns that you can adopt that increase your chance of success, but essentially your success with Kubernetes is going to be about your apps. Kubernetes may be commodity, but your success with Kubernetes is going to be custom to your own environment. When I talk about success, this is what I mean. Production applications, no more, no less. Despite the hype around Kubernetes, it's not a means to an end. We need to bring it back to the value that it delivers for our business. Is Kubernetes going to help you deliver for your users in production with those applications that they care about? Production is the happiest place on earth. It's not something to be feared. It's not something brittle that you never touch, that you never change. It's the place where technology delivers results. So this is what we care about. We care about delivering apps successfully into production for our users. And Kubernetes helps us to do that. But getting software into production is hard. And being good at delivering software is important. These are problems that many organizations are still tackling. The path to production isn't always easy. And a successful platform makes life easier for development teams to deliver apps. But in the same breath, we can also say that unsuccessful platform can actually increase complexity for dev teams and make it harder to ship applications. So we need to be really mindful about the outcomes that we're driving towards when we implement a new technology like Kubernetes. The popularity of Kubernetes was preceded by the massive popularity of Docker and containers. Developers love Docker. With Docker, we removed so many of those pain points on the path to production. I remember before the days of containers, when we were deploying apps into environments that were inconsistent, we had configuration drift between production and pre-production environments, which made it unreliable to deploy those apps. We spent our days and our weeks tracking down the many mysteries of why things worked in dev and not in test. And with containers, we found a solution to many of those it works on my machine problems that plagued software development from basically the beginning of time. This is my favorite Docker meme, but it's so true. When we package up our applications in containers, we build that runtime environment where they have everything that they need to operate successfully. And Kubernetes extends that experience. It says, actually, you know what? I'm going to handle how and where those containers run for you. So we have developers wanting to ship containerized applications in their hundreds or thousands. And we have platform people getting excited about Kubernetes as the new home for these applications. How do we bring these things together and ultimately deliver a service for our end users? Good fences make good neighbors, and knowing who is doing what helps us deliver value together. There are many ways to organize your teams, but this is one pattern that we found to be successful in many of the teams that we work with here at Tanzu Labs. So let's start at the top. The application team delivers apps. They're delivering a service for their end user. They build it and they support it. This is pretty easy to understand. The next level down, though, is exactly the same. The platform team are providing a service. Their users are the application developers. They're providing a platform service to their users. We've started to refer to this layer as an application platform, but I've also seen great content online where it's being referred to as an internal developer platform as well. But essentially the same is true. This team, the platform team, they're building and supporting a product. They're building and supporting a user experience for those developers. And of course, somewhere in there, there's also an infrastructure team, whether you're hosting in the cloud and that infrastructure team is someone else's team, or whether it's internal and you're running in your own data center. There's an infrastructure team who are providing that infrastructure as a service where you host your platform. But the important thing, again, they build it, they support it. They're offering a service to their users, and their users could be the platform team or it could be application teams directly. This is a really nice, simple model, and I find it a really helpful way to think about who's doing what when we're delivering services. But when we break it down a little bit further, it gets a little bit less simple. As a platform team, we're expected to provide solutions for a lot of the challenges here, whether that be data services, identity services, access control, service routing, storage, container networking, even things as fundamental as the container registry, cluster lifecycle management. This is actually a very large problem space. We're expected to do this not just for one application often, we're expected to do it for hundreds or even thousands sometimes of applications. So how do we navigate that amount of complexity and still deliver a compelling service? Don't do this. Well, this is an actual quote from someone I know in the DevOps community. We spent 150 million and all we have to show for it is a network diagram. Don't do this. Please, please don't do this. As a platform team, we have a lot of potential users and we have a lot of complexity to manage. With such diverse needs and increasing demands from development teams, it can be easy to get really bogged down in analysis paralysis, trying to solve every single problem up front before you deliver that service. This isn't going to get you where you need to go. Small autonomous teams are absolutely the right way to go if you can, but in a lot of large organizations, especially the organizations that I work with day in and day out, it's difficult to deliver value independently. We end up with dependencies between teams, between application teams, between platform teams, between like internal service providing teams. The technical landscape is really diverse and is also continuously changing and evolving. To scale, we need to work together. But as I said before, good fences make good neighbors. How do we set ourselves up for success and not allow ourselves to grind to a halt because we're all dependent on each other to deliver the services that we need? As I said, I'm going to advocate for keeping it simple. Navigating complexity is doable if you break it down into small, achievable problems to solve and you prioritize which problems to solve in what order. So I'm going to tell you a story now about two very different platforms, two very different platform teams. We're going to start with Clara. Clara is a single, solo, probably very lonely platform engineer, but she's embedded in a newly formed application team, a next generation application team in a really big company. Clara loves a challenge and she really enjoys experimenting with new technologies. She has a simple Kubernetes platform stood up in no time. She's going to hook it up to some monitoring tools, deployment pipelines, and hacks together a couple of integrations. The dev team that she's working with have all of the platform services they need, and they're delighted. They're able to ship those apps to production really easily using the toolkit that Clara's provided. Clara's platform is a success. People in the organization have noticed, and lots of other teams want some of that goodness. They want to ship their containers onto that platform. But unfortunately, this platform won't work for them. They have different security requirements. They need higher availability of the applications that they're building. And so at Really Big Co, they decide they need a really big platform. A new team is formed and they set about designing the one true platform, a platform for everyone, a platform for all of our application developers. And they're under pressure. They've got a really big investment to build this platform, the one true platform for everyone. They also need it soon. The increasing pressure of delivering applications at faster and faster velocity means that they have a deadline. People are waiting for them to deliver this platform now. They start to get behind schedule. They're suffering from the analysis paralysis I talked about before. They're trying to solve every single problem for every single user of their platform. They need to speed up, but actually adding people to the team only seems to slow things down. When we add people to a team, it feels like a really obvious way to add capacity and increase velocity. But as we add more people, we exponentially increase the communication overhead for that group. Suddenly we have a lot more people that need to learn this technology, and actually everyone is less productive as a result. So this really big platform project has a really big team. They missed their really big deadline and they've used up their really big budget. Suddenly it's a really big problem. And I wonder whether this sounds familiar to any of you, whether any of your organizations have leapt from that small scale success of a platform being built in a very application-centric way, embedded with an application team, to a much more challenging multiple user sort of one platform to rule them all approach. I think the early platform had some success because it was that small autonomous team, but it's been difficult to replicate that success at a larger scale. How do we get from that point to something that can be usable by all the application teams that potentially want to use it? Build it and hope is not a strategy. We need to be thinking about feedback loops. We need to be building something, seeing whether it works, learning from experience, learning in production, I would say. We need to be looking at those ways in which we can deliver small increments of platform features as rapidly as possible, and validating that they are the right thing to build. How can we prove that this is the right solution for our environment, for our application teams? How do we get a minimum viable platform into production quickly? As we said, production is the happiest place on earth. This is the place we care about. We need to get to production as quickly as possible to validate that we've built the right thing. So let me talk you through our approach to building platforms, navigating that complexity and launching a service that delivers value to your business as quickly as possible. We introduce a product manager, and I'll call him Ethan for this story. Ethan is a product manager, and he works in a small platform team with big ambitions. He knows that to build a valuable product, you need to get to know your users. So he identifies some early adopters. Partnering with his early adopters, he's able to reduce the scope of his MVP, his minimum viable platform. He's building a platform that delights this small group, and he knows that that's not the end of the road, but he also knows that he needs to start somewhere. By delighting this group of early adopters, he gets the fast feedback that he needs to validate that he's building the right thing. With a clear short-term goal, the platform engineers can focus on building that platform, and it's amazing how quickly they make progress. They have feedback, they have focus, they have prioritized which features they need to build today and which ones they can defer to down the line, which ones they can think about later. With a group of delighted early adopters, we can think ahead. Our product manager starts to build out a feature roadmap for the platform and identifies new cohorts of applications that can come on board at each stage. It won't meet everyone's needs, but the momentum is growing. We need to prioritize which features which will deliver the most value to our business in the next phase. And with more users, they can't collaborate with everyone in the same way as they did with the early adopters. Build, measure, learn got them this far in a collaborative way. Those fast feedback loops were implemented as collaboration, as conversations between the platform team and their first users. But they need to step back from that very high bandwidth collaboration if they want to scale. They can't work with every application team in this same high touch way. The communication overhead is becoming a problem, and the platform team are worried that they're going to be a bottleneck. This is the point at which I see a lot of organizations stumble on their platform journey. Are they building a platform as a service, or have they created a platform team as a silo in their organization? We need to think about how we deliver this capability internally as a service, as self-service. They invest time in providing documentation, templates, defaults, and tools so that their users can, by default, solve their own problems so that they can come on board in a self-service way. There are people on hand to help, obviously, but it's quicker and easier to get started using these assets that they provide without bothering the team every single time. They've taken a step back from that collaboration and they're providing that platform as a service. With the increasing demands and user base, there's a temptation to grow the team. Some growth is good, but resisting that growth is also really good for the team. We need to get into the habit of automating away a lot of the manual tasks so that we can scale the platform without scaling the team. They use automation to stay on top of their manual work as the platform grows, making sure that they always have time for feature delivery on the platform, or that they're not bogged down with the manual operational tasks of keeping the lights on. If you've read the SRE book, the concept of toil is talked about a lot, and toil is capped or recommended to be capped at 50% of our time. So, there is an element of sort of manual repetitive work that comes with operating successful platforms and successful services. But if we set a limit on it and we ensure that we use good automation and good engineering practices to automate away as much of that manual work as possible, then we can keep this team small and we can ensure there's always capacity to improve the platform. Toil is one part that's so often forgotten. It's not measured, it's not monitored, and it can get out of control. If we have to staff humans to do the work, we're feeding the machines with the blood, sweat, and tears of human beings. This is one of my favorite quotes from SRE. Automation is really a fundamental part of scaling any service that you're delivering internally. So this is one recipe that I would recommend considering if you want to scale a platform capability within your organization. Adopting these practices, and by putting people at the heart of your process, you can scale that success from one team to many teams. It's easy for us as engineers and technologists to spend a lot of our time thinking about how we scale our systems and architecture, and not enough time thinking about how we scale our teams. We spend a lot of time talking about what we're building rather than why we're building it and who we're building it for. I want all of you to go away today with big ambitions for your platform and for your applications, but I recommend taking small steps to get there by partnering with early adopters to build a delightful platform that satisfies a business problem, by managing your platform as a product and continuously evolving that platform to serve more users' needs, and to build towards platform as a service instead of creating platform as a silo within your organization. So remember, folks, I'll leave you with this thought today. You know, we are human, not superhuman. You know, we need to keep it simple. As we navigate this complexity, we can only focus on so many problems at one time. Don't try to boil the ocean. Prioritize relentlessly. Manage your platform as a product and delight your users along that journey. Thank you so much. I'm going to hand back over to Kote now. And if there are any questions in the chat, I'm going to go ahead and answer those during the next talk.
Well, great. Thank you very much. And hey, you know, since we can't applaud, if you, it'd be great if you wanted to show your appreciation to Hannah. You could just say thanks in the chat window or use funny little emojis, whatever you like. But it's always good to give feedback to something that was valuable. So next up, we're going to have Jakob go over, I think, you know, the kind of little bit of a layer above this when you're going through thinking about the design and architecture for your application. What are the current best practices that you can start to use? So I'll pass it over to you.
All right. Thanks, Michael. Hello, everyone. Good morning or good afternoon or good evening, depending on where you are. So first and foremost, allow me to share something. I will probably embarrass myself today. Why? Because that's the first time I'm doing this talk and I have 15 minutes, right? Correct me if I'm wrong. Yes, 15 minutes. So I will do my best. So Kote said before Hannah's session that it is probably beyond my capabilities to go over the questions and present at the same time. Challenge accepted. I will try to do that. If I fail, I will answer the questions after the talk. So I would like to relate to what Hannah said. There was a nice diagram on one of the slides. On top of this diagram, there was an application layer where developers are supposed to build business value. So from my experience as independent consultant before joining VMware and now at VMware as engineer, well, I get to face a lot of smart people. I get to face a lot of nice and challenging problems with architecture and modernization. So if we get that layer wrong, if we model our software and architecture wrongly, even the best tools down there in the infrastructure or platform layer will not help us if after a single change we have to, I don't know, redeploy 17 components. That's madness, right? That's why I'm doing this talk. That's why I would like to speak about how important it is to properly model software in the application layer. So I think there are effective that you, sorry, I have accidentally muted myself. I think there are at least two different that you can use to model your software and to measure the quality of your software. So people tend to talk about code, like does this method have less than 7 lines? Do you use optionals? Blah blah blah, things like that. Or you can use you can take a look at the model layer. So how do you model the boundaries? How do you put responsibilities between components? How do you communicate with each other? How do you spread responsibilities between modules, objects, microservices, etc., etc. So even though maybe our code looks nice, it uses the cutting-edge frameworks and so on, the model might not be that good. The consequence is that a single change requires many changes in your code base. By the way, it's a so-called shotgun surgery, when you want to perform a simple change and all of a sudden half of your code base gets broken. Or contrary, you can have code which doesn't look that good. Maybe there is a space for improvement, right? But if you want to improve a single piece of software in your system, that's easy to do because the model is right, because the architecture is right, because the responsibilities are put in a nice way. So the consequence is as follows. On the left side, well, you somehow manage to get it to work. The code looks nice, it uses optionals, but the breaking changes, which will happen, by the way, are, well, breaking. On the right side, the code doesn't look that bad, doesn't look that good. It looks like it was written in the 90s. Maybe we have long methods, large classes, but if you want to fix that, if you want to perform a breaking change, that's manageable. So I like to use this metaphor. On the left side, you have something which is very sharp, very nice, it's colorful, but it doesn't serve the real needs of the business. So it doesn't model the reality, even though it looks nice, right? On the right side, maybe you have nice foundations. If you want to polish something, that's easy to do if there is a need to do so. Well, it doesn't look that great, but it's close for improvement if you want that to happen. By the way, zima means winter in Polish. Probably I should have used a different drawing for that. Well, you got the idea, right? Hopefully. So how to overcome such problems and what are the common pitfalls related to architecture and modeling that I have seen throughout my career. So let's talk about an obfuscated scenario, because I cannot use the real cases I have seen at different organizations, but I try to generalize them and come up with a general idea. So let's say we have such business requirements. A borrower, so we are probably working at a payment industry, can become a VIP. Maybe they are no longer a VIP person, blah, blah, blah. What are the reasons for someone to become a VIP person? Well, maybe if you are more than 20, probably you can be VIP, but that's not the only reason. So if you had wrong birthday in our database, if it's corrected, maybe you are now a VIP person, or maybe you just turned 20, or maybe there are different reasons. Like if you have claims, we are not allowing you to become VIP, but maybe you revoke a claim. So now again, you can be VIP. Maybe only clients in Asia or in Europe are entitled for now to be VIP person because we want to dedicate our effort on this specific market. So there are multiple reasons to become VIP. By the way, this notation I'm using, the orange sticky notes, I hope it's orange because I'm colorblind, I have to admit that. Let's say it's orange. Those orange sticky notes, this notation of a business process noted as series of domain events, it's called event storming. That's a collaborative session you can have with your business people using domain events and place them on modeling space. That's a time lapse of one of the sessions I have had with one of my clients like 4 or 5 years ago. I don't really remember, to be honest. If you want to read more about this, I strongly encourage to take a look at Introducing Event Storming book by Alberto Brandolini. So you have those different reasons to become a VIP. And there is a nice architecture, I would say, solution to overcome such problem. You want to have a single source of truth of that information. Are you VIP? Or maybe you are no longer VIP. I don't want to ask around 1,000 services to get to know the answer, are you VIP? So I'm having one single component that answers the question, are you VIP? Well, what's the name? Maybe VIP service, I don't know. It might be a single module in a monolithic environment. It might be a physically separated microservice. It doesn't really matter from the perspective of that talk. But there is a trap in this. Even though the way of modeling software, thanks to this heuristic of single source of truth is nice, we might get into a problem. And the problem is as follows. Well, tomorrow we'll have different reasons to have extra limit, because you know what? If you are VIP, you have extra limit to be used. But tomorrow we want to apologize because there was some calculation that was done wrongly, and this miscalculation we have to compensate for. So we create an apology service. Why not? It's super simple, right? So I have to ask, are you VIP? Or maybe should I compensate in order to answer the question, what's your limit? Again, maybe in 3 weeks we want a new feature. Maybe we'll have special limits on special days, like maybe on weekend, maybe at New Year's Eve, or whatever it is, right? So we have more and more services. At the end of the day, it might be like we have 10 services and we have to ask them to answer one simple question: what's your limit? So it creates a huge communication overhead, and it creates huge problems when it comes to, well, delivering software if you have to ask 10,000 services to answer a simple question. So what's the root cause of that problem? The root cause is that we as developers, we as engineers, we don't dig it deep enough. Well, is that the final consequence that you are becoming VAP? I'm asking about business requirements that we might be looking at. No, it's not. We don't get a medal for that. There is no status in DB. That's the final consequence. We might model that with a status in a DB, but from the business perspective, there is something much more important to the right side of that process. Well, the borrower got some extra limit, and the borrower, they don't have extra limit at all right now. That's the consequence. That's the observable behavior that we want to talk about from the business perspective. That's the question that our component should be answering. So now it's not VIP service, but it's what's my limit service. It answers different questions. Sorry, it answers one simple question, but we might have different reasons to change the answer to that question. Maybe today you are exactly VIP person, maybe it's a special day, but it's private. And I have one component, again, inside of that component, I might have nice modularization, but those models, these are private. So no one will couple to them because I want to couple just to the observable behavior, which is what's your limit. If you have more changes to this answer, what's your limit? You will be changing one component. You don't need to add new service. You don't need to make your payment service aware of gigantic number of services to be asked. That's a common mistake I have seen throughout my career. And it creates a huge burden when it comes to the overhead from the communication between services. Another thing that we might be aware of is, let's take a look at this sentence. It comes, let's say, from the business requirements. An order has tax rules based on which an aggregated tax is calculated. Super simple, right? If we see that, well, I'm going to put tax rule list inside of my order class. And I'll have a getter because an order has a list of tax rules, right? And then if we calculate the tax rules, sorry, the aggregated tax, we want to first add tax rule to the order like this. Of course, we might want to do it in a better way without this getter, but it doesn't really matter. What matters is that what we do later on is, well, when we calculate tax for an order, we fetch the order, we get the tax rules, and we calculate the result. So if you take a look closely at this code base, an order is just used as a data placeholder for tax rules. So you might want to use you might want to have different placeholders in the order, and all of a sudden an order becomes a gigantic class which no one wants to touch, because, well, if something is really big, probably many different components are using this order class, which means if I touch it and I break it, many different consequences might be faced by me, right? So how to overcome that problem? The first thing that we might want to take a look at is that, well, I'm just using this as a placeholder. I'm putting something inside just for me to be able to get it back in the later time, right? So maybe if I do like this, if I just change the vocabulary, there is a vocabulary in the first 3 lines of code related to an order and then to the tax rules. Well, I might have this component, tax rule aggregation, which just takes the tax rules, right? So now I am able to calculate taxes for something which is not an order. Maybe it's a draft, maybe it's an order to be placed, not a submitted order. So I'm creating a huge number of business opportunities, and also I can somehow remove tax rules from the order. How? Well, I don't need to use the containment relationship. Like the order that doesn't have to use containment relationship and put tax rules inside. I can just somehow associate via link. Thus, makes our life very simple, because we don't need to grow this class of the order. But sometimes it's not that easy. Take a look at this. What happens if I have this order is payment delayed, then I need to add $2 on something like this? Well, in this case, we need to, again, separate the vocabulary. So let's separate the vocabulary related to an order from the vocabulary related and the language related with tax rules? Well, if we look closely, probably what we mean by that is that there is some delay penalty. What's the reason for this penalty? I don't care. In this specific scenario, that's the payment being delayed that causes the penalty to be added. But maybe we have a huge number of different rules. Look at this code closely, because now we separated taxes from orders. We not only allow our business to have new number of business possibilities like calculating tax rules for anything else than order, but also an order becomes a simple class without tax rules. That's so-called logical cohesion. So the worst kind of cohesion. Cohesion, by the way, is the degree of how things that are put next to each other are related to each other. Logical cohesion is a weak type of cohesion, which means, well, something looks like it's related, so I will be putting that in the same place. That's a wrong way of thinking, and it creates classes which are gigantic, modules which are hard to change because they have huge number of responsibilities. Same applies to a different thing. Well, maybe I put tax rules inside of an order because I want to, well, have a screen which shows an order with all of the tax rules applied. That makes sense, doesn't it, right? But you know what? Tomorrow, maybe I will have addresses as well. I want to have a different screen. I want to have a different view with addresses. I want to have different view the day after tomorrow with all of the discounts applied. All of the sudden, after 2 days, I have 17 dependencies in my order class. And again, it becomes a gigantic model that no one wants to touch. What's the root cause of that? Well, in this case, it's temporal cohesion. What does it mean? Because temporally, I want to associate order with discounts, addresses, and tax rules for the sake of, for the time of showing a screen, a view. That's why it's temporal, but it's not constant. We don't need to use containment relationships. So a class contains other classes when all we need is simple association via link, via foreign keys, or whatever you use. This way, we are going to have better architecture, smaller classes, and nicely focused responsibilities. Another example is as follows. After 200 withdrawals, client, they get a bonus. A bonus is just a simple withdrawal of 100. So we already have a withdrawal service in our code base, in our architecture. Well, bonus is a new word. So I will create a new microservice because that's a new concept. So I need to have a new model, new microservice, physically deployed. And how does it work right now? Well, the bonus service has its own database, and it has to gather all of the information about the withdrawals via events or maybe via some queries which are scheduled every 2 seconds or something like that. I'm gathering information and I'm doing some if statement. Maybe after some time you will have a free withdrawal because a threshold is being met or something like that. Notice what's happening right now. All we have done is a cyclic dependency between 2 different modules, and withdrawal service is just creating data for bonus. Bonus is just doing some calculations and then going back to withdrawal service. If I don't need any specific performance architectural drivers to have such kind of separation, it doesn't make sense, right? Because if bonus doesn't work, if withdrawal service doesn't work, bonus service is useless. Probably if I see this cyclic dependency and I don't need any strong performance requirements, probably that's a simple model inside of my withdrawal service. All I need is the data from this service, and all I need to do as a consequence is to change data in the same service. So why separating that? If I separate that, again, that creates a huge complexity in my architecture if I follow this pattern in every place of my code base. All of a sudden, I have gigantic numbers of microservices, and all they do is talk to each other in order to come to some conclusion like, well, I need to add a free withdrawal. Doesn't make sense in the long term. One of the last examples, because, well, I'm running out of time, 2 minutes more, I promise, is related to invoicing. Let's say we are in an invoicing department or maybe in an invoicing industry, and we have such a code base. Well, I have this use case. I need to issue an invoice. That makes sense since we are in the invoicing industry, right? And the code looks like this. If client is company client, then we have to do something else. If the client is the individual client, we have to serve that differently. That's, I would say, sane if statement when it comes to invoicing industry, right? Then we have a new use case, issue pro forma invoice. And again, we do that differently when it comes to company and individual clients. And then we have to cancel the invoice. And again, we have two set of instructions, two different kind of logic when it comes to company and individual clients. So notice what I do. All of the time with every single use case in my module or service or whatever we call it, I do an if statement. So probably I'm talking about two different modules that need to be created out of this one gigantic module. I call it schizophrenic module because all it does, it doesn't know what it is. Sometimes it's a company model, sometimes it's not. And probably it doesn't have a sense what's the main responsibility of that module. If you see this branching logic in all of the use cases in one single module, probably there is a missing module inside of it. Well, that was the last use case. If you want to know more, if you want to hear more about those architectural pitfalls, modeling pitfalls, and why it's important, I'm happy to talk with you via Twitter. Probably that's the best way to reach me. You can see my Twitter handle in the right bottom corner of this slide. It's @JakubPidemo. And thanks for having me. I promise that I will be trying to answer the question during the talk, but yeah, I failed. So maybe now is the time for that. Thanks.
Well, that was great. Again, if you want to show your appreciation, you should just write a little thanks for Jakub in the chat window there, or however you want to show him that. It's always nice to get some thanks. Now we're about to get into the other meat of the day, or delicious vegetables of a savory type, if you prefer, and that is the workshop. Now there's two instances running. You can, you'll be able to go into whichever one you prefer. And again, if you have questions that you want to ask either Hannah or Jakub, feel free to write them in the chat window, or the alternate ways that they suggested you contact them. And I just want to remind you, if you want to, after this or whatever, you can always go to the Tanzu Dev Center at tanzu.vmware.com/developer. And you can find all sorts of detailed technical articles, things like that. And also see when there's more SpringOne tours coming up if you enjoyed this one, and check out the big conference we have coming up, SpringOne, in September. And check out your email after this event for links to everything that you've seen, other content, and a limited edition Booternetes swag item, a little way to remember your special day here with all of us. So now, if you want to access the workshop, there'll be a link in the chat window. You can click on that link and log in with your GitHub account, and you can start going through your workshops. And remember, in the workshop, if you want to ask questions, the instructors are there to help out. You can unmute your microphone and ask them in an orderly way, being polite. And whenever you're done with it, you can drop off whenever you like, or stick around. Maybe you want an official excuse not to have to get to more boring things, so you could just be in the workshop. And you can check out the developer site, anything like that. And with that, again, let's give a big thanks to our two keynote speakers here. And I hope everyone enjoys the workshops. Thanks, and have a good time with that.